So having sort of introduced the very basics of pure data, I now want to segue into talking about open sound control, because what you're most likely going to be doing in this subject is linking processing and pure data together. And we need a mechanism to do that. We need a way to kind of pass messages between your processing sketch and your pure data patches so that your users can kind of have a coherent experience. So yes, often in interactive media work you need to pass data between two applications. Sometimes those two applications are just running on the same machine. That's most likely going to be the case for the assignments you're doing for this subject. But often you might want to have two machines or more machines sort of splitting up the various processing tasks that are associated with your application. For example, you might want to have real-time video analysis running on one machine, so a machine connected to a camera, and that computer is doing figuring out if people are moving around in front of the camera, and maybe doing skeleton tracking or something like that. So you might have that video analysis running on one machine, and then audio processing running on another machine. Or you might have video analysis running on one machine, and more sophisticated output graphics running on another. You could also have a user interface controller running on the iPad, which sends control messages to a laptop which is producing sounds and visuals. It's a very common setup. Or you might have some interactive interface running in processing, so you might have your user interaction happening through processing, but you want your processing sketch to trigger sort of audio which is being created in pure data. One very useful tool that you might find handy for your assignments is this application called TouchOSC. No, it's not free. I think it costs about $6 or something like that, so it costs maybe a couple of cups of coffee. But if you're doing anything to do with audio, or if you want to kind of give your users a separate device that they can, with lots of different sliders and buttons and controls on it, if you want to give your users a device like that, which is nice and neat and sort of separate from the computer, this can be a great tool. Basically, you create your own layouts using all these user interface elements, sliders, buttons, XY pads, a huge range of really nice looking user interface controls that are kind of generally oriented around audio visual work. But you create your own layouts with whatever user interface components you like, and then when your user uses it, the iPad or the iPhone or whatever you're using it on sends the output from those sliders via the Open Sound Control Protocol to your computer, and then you can then sort of process them in processing, or you can, or pure data for that matter, or anything else really that can receive OSC. So Open Sound Control is a very useful protocol to use for this kind of thing. It's very simple, and it's for sending messages over the network. But of course, you can send messages on the local machine as well. You don't necessarily have to use a physical network to send these messages over. And for those of you that are familiar with musical stuff, you would have heard probably of MIDI. MIDI is a protocol that's been around since the 80s for doing interactive, for doing sort of real-time music stuff and linking together, say, keyboards to sound modules, stuff like that. A great protocol, very widely used, but it does have some limitations, and it's not easily kind of extensible. And you find Open Sound Control is sort of like the replacement for that. It's supported by many interactive media applications, such as processing of pure data, but also Max MSP, Ableton Live, Resolute Reactor, most of the digital audio workstations that are around, also things like Super Collider, etc., etc. So there's a very wide range of applications that can use this. The messages have a pretty simple format. You have an address pattern, which is basically an arbitrary set of strings. You can determine what these strings are, but the address pattern sort of starts with a slash, and the strings are separated by other slashes. So an example of an address pattern might be /audio/volume, or /output/audio/playback/reverb. But what these messages are here are arbitrary. You could call them anything you like, but normally you name, like variables, you name them something that's meaningful to you and that others are going to understand fairly readily. You also specify in the OSC protocol, you specify what type of values you're going to be sending that are associated with this address pattern. Like, are you sending numbers or strings or floats or anything like that? And also the arguments, that is the actual data that you want to send, whether it's numbers or strings or whatever. Yeah, so that's Open Sound Control. And in Pure Data, there is a special library, Mr. Peach library, that has a bunch of Open Sound Control objects in it. So let me show you those and give you a sense of how they work. So what we're going to do is hook up a very simple processing sketch, which simply draws a circle, with a Pure Data patch. And what we want to be able to do is control the size of the circle from our Pure Data patch, and we want to be able to send from our processing sketch the mouse position, the mouse cursor position back to Pure Data. So it's a very contrived example just to show you that I'm sending data from Pure Data to processing and back again using the Open Sound Control protocol. So the objects that we're using are TouchOSC and UDP send. So TouchOSC takes a message with a processing, with an Open Sound Control message in it. So in this case, we're going to be sending address pattern. We're going to be sending, the message has the address pattern in it and also a value. So in this case, we have the address pattern is processing / circle size, and the value is whatever number I send from this message box, from this number box here. And that is going to be formatted into an OSC message by the TouchOSC object, and then sent over the network, although actually only sent over the network on the local machine. It never actually goes over a physical network, it just goes through the network stack on this local machine to a processing sketch. So what I'm saying is to connect to localhost 127.0.0.1, which is this machine, on port 12345. So we can specify whichever port we like, really, as long as the processing sketch is listening on the same port, then it will receive these messages. So that's the sending part of Open Sound Control in Pure Data. If we open up our processing sketch, which is receiving this data, we use the OSC P5 library. So this is a library that you add to processing. And most of this sketch is pretty straightforward. It just draws a circle that we've done many times before in class. I guess the interesting thing to look at is that we're using the OSC P5 library. We create a new OSC P5 object and tell it to listen on port 12345. So that's the same port, of course, the matching port that I had specified in my Pure Data patch. So as long as we're listening on the same port we're sending on, we should be good to go. So I create a new object to listen on that port. I'll get to this one later. And then we implement a method which must be named OSC event, which is triggered automatically by processing when an OSC message is received. And so in this method, we're not doing very much except printing out the message that we received just to show that we got it and what the type and the arguments were. But then to make it do something more kind of immediately visible, I'm saying, okay, let's make the size of the circle that we're drawing value equal to whatever the value is that we're receiving in that message. So in other words, whatever number I'm sending through this chain here from pure data should be setting the size of the circle in our processing sketch. Okay, so let's start up the processing sketch. There it is, so it's drawing a circle of some arbitrary size. I'm just going to click on this message here to tell the UDP send object to connect to this computer localhost on port 12345. That seems to have worked well. UDP send sent the message out, it's out, that's indicating that it's connected. So now when I drag this number up, we should see the circle size in processing be changed. Interestingly, negative numbers work just like positive ones. Okay, so you're seeing there, we're sending an OSC message, Open Sound Control message from pure data to processing. Now what we're also doing is our pure data patch is receiving OSC messages. So I'm saying here, use the UDP receive object to listen on port 12346. So not the same port we're sending on, a different port, the next port, the adjacent port, I guess. So it's port 12346. And whatever message we receive from that, we unpack the OSC. It's an object that sort of processes the OSC message for us. And then we say, okay, whatever that message has a address pattern / pure data, send that value out this outlet. Every other OSC message which didn't match that address pattern would be sent out the other outlet. And in our processing sketch, so all we're doing here is receiving a number from our processing sketch and we're displaying it. In our processing sketch itself, in our mouse moved method, so this is a method which is called automatically by processing whenever the mouse is moved, we're creating a new Open Sound Control message and telling it to use this address pattern / pure data. We're adding the value of the mouse X coordinate to that Open Sound Control message, and then we're sending it. So we're constructing an Open Sound Control message with the address pattern / pure data. We're adding the mouse X coordinate to that message, and then we're sending it to my remote location, which we've defined up here as being, again, 127.0.0.1, the local host, this machine, not sending it over the actual network, and importantly, port 12346. So our PD patch is receiving on 12346, they're sending on 12346. So in other words, when this sketch is running and my mouse is in the window, you should see that as I'm moving it, my X coordinate from the mouse is getting sent across to the PD patch over here and displaying that value of that coordinate. So again, very simple and a fairly contrived example, but hopefully you get the concept of we now have a mechanism. We now have a mechanism that we can use to send messages from pure data to a processing sketch and back again using Open Sound Control. So it opens up a lot of possibilities for doing interesting things. It means we can use pure data for digital audio, which is what its strength is, and we can use processing for visuals, which is what its strength is, and we can get the best of both worlds by sort of triggering events and sharing data between the two using Open Sound Control protocol.